When you are supervising network infrastructure devices like switches and routers, generic information could be enough. PRTG from Pessler offers this generic information right out of the box, with no additional configuration required. But as an administrator for critical networks, you need access to more comprehensive information. In this video, I will show you how to display additional vital information about your Hirschmann products directly in PRTG. I selected 6 functions because the information is genuinely interesting for live network operation. But the principle is the same for any function which is available via SNMP. There are 4 stages to this information display process. First, I'll create an OID library file containing the SNMP parameters I want to supervise. Second, I will import the OID library into PRTG. Third, I will optimize the displayed information. And finally, I will create a template that can be applied to other HiOS devices. Let's get started. As a starting point, this is what the Hirschmann BRS looks like when it's discovered in PRTG. The sensors are either generic MIB2 values, or they are derived through the communication between PRTG and the BRS. My objective is to add some manufacturer-specific sensors to the BRS. I want to add values which are specific to the HiOS operating system. For this task, there is a direct correlation between a sensor and a MIB variable. In the small notepad window, you can see the 6 MIB variables that I want to import. You can also see which MIBs contain these variables. For the first step, I will use the Pessler MIB Importer tool to generate an OID library file. This library file will contain the information that I want to add. I'll import the parameters into the OID library file from the private Hirschmann MIBs. I am selecting the MIBs that I need to import. The 2 additional MIBs are necessary as they contain information required by the other MIBs. The MIBs are being processed. The summary shows how many MIB variables, or items of information, have been imported from each MIB. Of course, this is much more information than I actually need. By default, the MIB importer will import all items from each MIB. I've selected the Enable Partial Selection option, as this allows me to select only the items that I actually want to include. So now I need to find the relevant information. I'll work down the list in the Notepad document. So the first item is temperature. I check the box for the value that I want. Useful descriptive information appears on the right. I would like to be able to edit this information, for example, to change the temperature unit to degrees Celsius. But this is not possible in partial selection mode, so I'll do the editing later. Next, I need to find the information about the auto configuration adapter, the ACA. Notice the lookups in the bottom right field. The lookups define the meaning of each numeric value which is returned by the BRS for this parameter. I'll show you these lookups in more detail later. That's it for the Dev Management MIB. Now I'll move on to the Diagnostic MIB. The devmon trapcause is a useful MIB variable because it provides a summary of what function is causing an error on the switch. I want to include this variable because it will give the network operator a quick point of reference if there is a problem with the BRS switch. Next, I would like to know the status of the MRP ring redundancy. High discovery is a useful function when first commissioning a switch, but it's a security risk during live operation, so I want to be informed whether it has been disabled. Finally, I want to check the power supplies. If you are using both power supplies for your switches, it's really important to know if one of them has failed. Now I'll save my selection using the partial selection option. I'll give the OID file a meaningful name, as the name will be used later in the PRTG software. I'm saving the file in a temp folder because this is not the final version of the file and I do not need a permanent copy. I now want to open the partial OID file that I just saved. I no longer need the file which is currently open. I have now opened the original partial OID file as a full OID file. You'll notice two things. Firstly, the file only contains the MIB variables that I previously saved. Secondly, I can now edit the identification fields. I want to edit these fields to make sure that the information is correctly identified when it's imported into PRTG. In the case of temperature, I also want to customize the unit. I will now modify the information for the other 5 variables. To save viewing time, I'll speed up the video. Now that the identifications have been updated, I'll save the information as an OID library file. I'm running the MIB importer on the same PC as the PRTG server. By selecting Save for PRTG Network Monitor, I know that the new OID library file will be saved into the correct folder. If you are running the MIB importer on a different PC to PRTG, you will need to move the new OID library file manually. Okay, we've built the OID library containing the required sensors. The next step is to import the library into PRTG and add the sensors to the existing BRS switch. Once again, here is the BRS52 with the standard sensors. I want to add the sensors I prepared previously. To do this, I need to search for the SNMP library sensor that I created previously. As you can see, PRTG already offers some standard sensor libraries. You can also see the HiOS sensor library that I created earlier. When I select the HiOS library, I see the customized sensors. Even though I only created 6 sensors, 7 are displayed. This is because the BRS has 2 power supplies. There is an option to trigger a change notification if the value of a sensor changes. Rather than select this for all sensors, I prefer to do this later for the relevant individual sensors. I just select all the sensors and create them. And there they are. The sensors are grey because they have not yet been polled. You can force PRTG to poll the sensors, or you can just wait for the polling. The sensor names are not friendly. It's not possible to give the sensors meaningful names during the creation process. But you can see the sensor purpose in the graph column. So I will now edit the sensor names. I'll speed up the video to save time. The power supply entries are read from a table, so they are listed in numerical order. Wait for the sensors to be polled again. Okay, the sensors are being polled correctly. The sensors now appear within the BRS52 device and are displaying actual values. Things are looking good. The sensors are associated with the BRS switch. PRTG is polling the sensors and the values will be updated regularly to reflect the actual status of the switch. But if you look closely, you see that the display could be improved. So that is the next task. The sensors are now being read correctly, but there is still room for optimization. Firstly, the statuses are being displayed in green or OK, even when the value is clearly not OK for live operation. Secondly, the values of the sensors have been taken directly from the MIBs, so they are not in good English. To fix this, we need to manually edit the lookup tables. The tables are in the Lookups folder. By default, this folder is read-only, so I'll modify the attribute. The lookup tables for the new sensors were created automatically and stored in the Custom folder. There are three important parameters in each table. Value is the numerical value returned by the MIB variable. The words following the value are the text which will be displayed in PRTG. State is the status color which will be displayed for the sensor in PRTG. The possible values are none, green, OK, green, warning, yellow, and error, red. I'll modify the lookup table to display the correct status color and good English text. This needs to be done for all the lookup tables. I'll speed up the video. For the changes to take effect, the lookup tables must be reloaded into PRTG. This can be done by restarting the PRTG server service. There's an option to do this within the PRTG interface, but it's quicker to do it manually. Now the status color of each sensor is displayed correctly and the text is in good English. You will not want to configure the sensors for each HiOS device individually. So PRTG offers a function to create a device template. This can be applied to devices automatically during the device discovery process. The template can be created directly from an existing device. I'm happy with the information made available for the BRS switch, so I will use this switch as a basis to create a template for all HiOS devices. I do not want to exclude any sensors, so I'll just click OK. I'll now manually add a new device. I picked the GRS-106 because it's different hardware but still running HiOS. I select the new HiOS template. Now I need to wait for the auto discovery process. Sensors from the HiOS template have been added automatically. If a device does not support a specific MIB variable, the relevant sensor will not be displayed. And that's it. Through 4 simple steps, I've made valuable information available for these critical devices. As I mentioned at the beginning of the video, I selected some switch parameters which I believe should be monitored in a critical network. But as a network administrator, you may have a different focus. Whatever information you require, the process is the same. I hope you found this video informative. Thank you for watching.